Thank you for joining today's webinar on this important, crucial topic, sustainability in streaming, how to reduce the carbon footprint. We'll be discussing ways of how to optimize the energy efficiency of TV and video delivery across the whole chain. And as I'm mentioning this, you already see that there's a lot of aspects involved alongside this chain. There's the broadcasters, there's the platforms, the operators, service providers, CDN networks, delivery methods, standards and specifications, of course, and right at the end, it's the consumer, of course, who has some certain aspect of influence, of course, in how to optimize these ways. And a couple of messages first on organizational matters. We have 125 registered viewers for this webinar today, which is quite good, showing that this is an important topic in the industry. If you don't manage to watch this live or you'd like to recommend the webinar to a colleague, there'll be a YouTube recording on the HbbTV YouTube channel as usual. And of course, we'll provide you with the presentations as PDF downloads after this webinar on the HbbTV website. First of all, quickly going through the lineup of speakers. First, we have Ben Schwartz, who's the president of Greening of Streaming, who's going to give an introduction on the topic. And then we have the broadcaster perspective and also the perspective of creative talents and how they can influence the chain. Hemini Mehta, Senior Sustainability Lead at DVB-I, is going to host this presentation. Then we have Vincent Grivet, the HbbTV Chairman and also representative of the LowCat project, who's going to give us an update from this part of the industry. Then we go more into a deep technical dive with first Robert Selinger, Senior Project Manager, Future Applications and Media, DII Lead at Fraunhofer Focus in Berlin. And also from Germany, Peter Broxeber, Senior Project Manager, Deutsche Telekom Labs, who's going to give us a real deep dive into the technical aspects. And as usual, after the presentations, we have a 15-minute Q&A for you. We're collecting all the questions, and please send them through the question box of this toolbox, which you can see, and we'll collect these questions, and at the end, we're happy to discuss all of them with the speakers. So get ready for these last 15 minutes. They're always very exciting because sometimes they're covering aspects that we haven't thought of when we prepared this webinar. First of all, I'd like to welcome to this virtual stage Ben Schwartz from Greening of Streaming. Welcome, Ben. We're very keen on hearing your presentation.
Thank you very much.
Thank you. Joining us from Paris, is that right?
That's right. From, as you can see, sunny Paris.
Excellent.
And I can even share my screen. That should be working. So yeah, I'm going to talk to you for less than 6 minutes. Oops, what am I doing? Pressing the wrong button.
This is live.
So I'm president of Greening of Streaming. I'll give you a few quick words about what Greening of Streaming is and what we're trying to achieve. And then I'll dive into just one topic. It's such a wide topic, is how do we measure? Because this panel is about improving the situation, but before improving it, we have to have some kind of understanding of where we are and how we measure any progress. So I'll just tell you about that aspect in today's quick presentation. So who are we? Greening of Streaming is a non-profit, member-driven organization. We currently have 24 members. We're all about the keywords on the left. I want to spend my time on what we're doing rather than who we are. So you can just see we have here on the right 7 different working groups. 5 of them are very active. We're seeking leads for 2 of them to get them back up. We run hackathons at least once a month, and I'll tell you a little bit about that in a minute. We have monthly member meetings, and of course all the working groups have typically monthly meetings. So that's who we are. You can see there some well-known names, others maybe less well-known. We have some, big companies like Akamai is founding member, Eutelsat's one of our more recent members. People around the table here like Fraunhofer Focus are affiliate members, and so that's who we are at the moment. So I said I'm not going to give you all the spiel about everything, who we are, what we think. I just want to go straight into how do we collect energy data. So this was our kind of founding diagram when we set up almost 4 years ago from Dom Robinson, who founded the organization. And there's almost 60 different boxes there. When you start creating a live encode here, you can go through 60 different devices before the client gets it. And so we work on different aspects of this. We're trying to do to get a grip on it. So we've had to simplify it, of course, and we've built a platform that's called REM, for remote energy measurement. And that platform, so there's the same diagrams from the start to the end, but here we only have basically 3 parts to it. The encoding part, sort of head end part, the devices, and then 2 sections in between, the CDN part, which we split into 2, and the telco part. And so the lime green colors, they're live. They've been live for almost a year. We're doing measurements. I'll share a few little snippets of what we've measured and understood so far. And this is a live platform where the devices, whether they be servers in a server rack or devices in people's homes, they're all connected to power plugs, which we can poll live and get telemetry in real time. And so we learned some really exciting stuff, and I'm very excited that these parts were not quite yet live yet. We actually have a live server that's been provided for us by TNO, and we're just about to set up some software on it to start putting this light blue part of the equation into our work. So briefly, the kind of things we find out. This is just, again, so here, this is an FFmpeg encoder sitting in the University of Bristol. You feed it a file and you just say, please use H.264 or please use H.265. What does that do? Well, that really changes the encoding profile. Kind of, it doubles from 140 to 220. Well, that's not quite double, but nearly. The power required to encode H.265 versus H.264. And we were quite surprised, and we don't yet have the full explanation, is there does seem to be a relatively systematic higher requirement to decode H.265 compared to H.264. And we can do that kind of thing. We have the data with HD versus 4K, HDR versus SDR, all the different parameters we can play with. We're going to go much deeper into target bandwidth and aspects like that for the encoding side. Here's some fresh off the press. This is data that came from last week, so it's not been fully analyzed yet. It's a bit of a mess, but just to show you something quite exciting, we're all currently maybe up to 120 of you guys listening to us on video. So we did a video conferencing hackathon, and we had loads and loads of test cases. You can see there with audio only, with sharing black screens, doing all sorts of stuff. But just one lesson from this. Here we had video on, here in all these tests, the video was off and the video was back on in all these tests. And just look at that. I mean, we're talking around a bunch of devices going around 15 watts to going to around 25 watts. That is the power requirements of computers without screens. So the processing power, we knew there would be a significant processing power uptick. This is Zoom as a client, not GoToMeeting, which we're using today. But Zoom really has a massive impact when everybody turns video off. So that's one quick learning. And you can see in there, we did lots more detailed stuff on sharing, black screens, white screens. Here's a quick little jump in to say that, you know, you need milliwatt measures to try and understand the screens. At this level, at the watt level, they're flat lines, the screens. But then if you look here at the axis here, we're going from, these are milliwatts now, no longer watts, so this is 23.8 watts to 24.6 watts. So there's a 0.8 watt variation here, but there's some really significant jumping up and down. And when you're streaming something to 10 million, 100 million, a billion devices, that does make a difference. And these are PC screens, because we're talking about video conferencing. All this in TVs is much, much bigger. So that was just to show you we need to go to milliwatts. I'm already running out of time, so I'll just finish off with 2 more things. eYang is another project we do, which is to try and push into IETF and other places the idea that we should be able to talk to devices on the network and say, hey, Mr. Encoder, hey, Mr. Set-Top Box, how much power are you currently using? There is currently no way of doing that. And then I'll just finish off with this slide, which is very, very preliminary, but we've decided in our organization, we're sitting on a gold pile of stuff we found out over the last 4 years, and we're quietly working on it to try and make it perfect before we take it out to the world, because we don't want to bring uncertain things, and we decided we can't work like that anymore. So starting now, we're going to start talking about the work we're doing, and starts we're kind of pretty sure, and these are what kind of recommendations could come out of greening of streaming. It's very preliminary, and there's some really simple ideas like getting users to understand how important their ambient light is. There's some more sophisticated stuff here, and we're working on that. And with that, I just like to say that we're an open organization. We're currently seeking new members and people to work with to join us in different things. It's an exciting, we're building a community, and please join.
Thank you. Great to see so many big names involved in your organization. So yes, and please join Greening of Streaming if you're looking to discuss these topics and make progress. We're not going to switch off any videos to save energy, but we're going to change the video now so thank you, Ben, for this. We'll see you again at the end, to Hemini from the EBU to take a look at the issues from a broadcaster perspective. So we're looking forward to your presentation, Hemini. And please don't forget to submit your questions if you have any for the Q&A at the end. There should be your presentation coming up in a second.
Yes. Thank you, Johan.
Still the wrong screen, but it's slowly building up. There's always a bit of latency involved, and here we are. Thank you.
Perfect, thank you. So I won't say who EBU is. Most of you have all worked with EBU in some form or another. So I'm Hemini Mehta from Technology and Innovation at the EBU. So I'm looking at it from the perspective of broadcasters, which makes sense. So here, what's happening at the moment? So here are some of the conversations, numbers, etc., that we're starting to get. Broadcast TV weekly reach in 2022 across Europe was something like 79%, and then in 2023 it went down a little bit to 75%. And this is something that we've started to notice across some of our members. At the same time, Ofcom in the UK said only 48% of 16 to 24-year-olds watch broadcast TV. So this is a story that we're starting to hear across, as I said, some of our members, that they're starting to lose some of the younger audiences through traditional linear television. But at the same time, the story across Europe is very different. So traditional TV in 2024, approximately 60% of the video consumption was through traditional TV in France, Germany, and Spain, and was a little bit higher in Italy, which was across almost 70%. But the UK, you can see, is drastically different to the rest of Europe, which was at 55%. So the story is not the same everywhere today, but there are patterns that we're starting to see, which is as you keep hearing about younger audiences and losing them a little bit. So what don't we know? So one thing we do know, and I know Vincent will talk about it more, but we know operationally that with streaming, the end user devices consume more energy than the distribution chain in itself. But what we don't know is the energy use of the end user devices, because it's just really difficult to understand how the devices, how much energy they're consuming. The TV manufacturers, even within their own models, change the lower technology, etc. So each one can be completely different. And then if you're in reporting, we don't know when content is being watched, whose scope 3 does the devices and the content being watched fall under. So this is a big issue when broadcasters or content providers are actually doing reporting, because we don't know how to measure our consumption of our products and services, which is one of the main things that if you're, for example, a TV manufacturer, you can say and estimate your carbon emissions of your actual television set, but we can't do the same for our content. So we don't know where the energy use of our supply chain is. We don't know what it is, and we don't know who it falls under. And what we do know is, at least in the streaming world, there are so many stakeholders, from CDN providers to cloud storage to encoders to the telecom users, caching, etc., etc. So it makes it really difficult. On the content side, we know there's been research to reduce the light in TV sets. So Interdigital and BBC have been working on this independently and doing some research around it. And the BBC found that across all genres, on average, 20% of energy can be saved depending on the genre, as I said. And sometimes actually reducing the light and having darker pixels can improve the image. So there was, if you were in IBC 2 years ago, you might have seen the BBC screen split, and you could have seen a live, well, it wasn't a live, but at the time they were recording a football match. And sometimes, in some cases, the darker pixels did look much better. The other issue is the creative intent. So in this content world, we have a lot of stakeholders, as I said, and the directors and the people making the content have a certain way that they want their content to look like. And if we start changing this, we being the collective we, what does that mean? And that can become quite an issue, especially maybe not so much for the usual genres, but when you're thinking about big dramas and films, etc., there's a way that some of the artists have thought about how they want this to look like, and it can become it can be a touchy issue because they want it to look like a certain way to their audiences, because that's how they filmed it, that's how they've added money into making the content, etc. And then we come back again to the stakeholders. So how many stakeholders are there in the streaming chain, and who's changing the content? So for example, as I said, there's the work that Interdigital and BBC have been doing. In the BBC's case, for example, it would be the broadcaster doing the changes. But equally, we know that manufacturers of devices also have started to look at sustainability and trying to reduce the energy usage in that. And so they could be changing the content. So we get to a point where nobody really knows who's controlling the content and who's changing it for the look and feel, yet we have all these stakeholders. But what we do know is that the broadcasters want to have more control over their content, so they can align to the creative intent, and they have a chance to look at the content to make sure that it's the way they expected it to look, because obviously at the end of the day, the quality of the content sits with the broadcaster. So if there's an issue at the end user side, it's the broadcaster's brand and publicity that's going to be looked upon, not necessarily the manufacturers of the devices. So what can we do? We can provide data and metrics. So Ben already spoke about it. We know it's this big chain, but we do need to start measuring it and looking at it from different levers and pulling different levers, which is something that we're trying to do at the moment as part of, at least on the distribution side, through various accelerators, etc. We can be transparent, because as we know, changing something on one side doesn't necessarily mean that the energy usage is going to reduce. So we all need to work together in order for that to happen. We can try and find efficient distribution channels that would help on the quality, latency, but also looking at it from the sustainability side of the end of the view, seeing how we can reduce the energy on that. Understand that sustainability is more complex than we know. We've been working on the tech side for more than 4 years, 5 years, and we haven't really moved and we haven't made huge leaps. So that's something that we need to do and need to understand, that technology is consistently moving forward, but is more complex than we understand it as. And share output. Even if it's not perfect, please share it, because we find that a lot of standard bodies, also other organizations, etc., sometimes we're doing the same duplication of work. So why not pull together and work together on this side of things? So please do let us know if there's any work that's being done out there by yourselves. So that's it from me. So I'd just like to thank you, and I'll pass it on to whomever else is next with you.
Already waiting for us. So thank you, Hemini, for these insights from the broadcaster's perspective. please make sure you direct any questions to us through the questions button, and we're happy to respond in the end. Now we're back in Paris, where Vincent is waiting for us and going to give us more insights from the HbbTV and LOCAT side of things.
Thank you, Jörn. Actually, it was the wrong Vincent that you invited to share screen because I'm struggling with the two computers. Sorry for the complexity.
Okay.
So if you give it another try to make me share. Yeah, now that's the good one. Don't change anything. And that's the good one. I'm sharing.
Right, there's your presentation.
And here is my presentation. I go to the full screen mode
And
we should
perfect. Thank
Here
you
we
very
are.
much.
So thank you very
Looking
much,
forward
Jörn.
to it.
Thank you for inviting me to this interesting webinar. This is a topic which I find very interesting from actually several perspectives or occupations of mine, both from HbbTV and from my activity in the LOCAT project. I will focus on the delivery of TV, which maybe is not the biggest part, as we learn, where the TV set is a big part, but still what I will try to evidence in my presentation is that the TV delivery, so really transporting the images to the consumer, is not something totally insignificant, and there are things that can be done to improve the situation. First of all, how bad is the situation? And this is a dense graphic, sorry for that so early in the morning, that is summarizing the key figures from the LOCAT study done in 2020. One important caveat is that in this 2020 version of the LOCAT study, we don't have satellite and cable. There is an update or a complement which is ongoing where satellite will be added, but I believe that nevertheless, the conclusions are already important. If you look at the very left bar, you see the estimation done by LOCAT of how many hours of TV people are watching in Europe. Close to 300 billion hours of TV. And as you can see that about half, the green part at the bottom, of these 300 billion hours are delivered by DTT. A third, 95 billion hours, the blue bar, are delivered in OTT. And about 20%, 53 billion hours, are delivered in IPTV. If you move right to the next vertical bar, you can see what is the attributable energy used for the delivery of these hours. And what you can see is that DTT in green, which is delivering about half of the hours, is using only 10% of the energy. OTT, 32% of the delivered hours, 50% of the energy, and IPTV, 18% of the volume, only 40% of the energy. Total energy consumption in Europe, estimated in LOCAT, for the delivery of TV signals is close to 21,000 gigawatt hours. If you want to know what it means, and actually I need to do one more click, the average production of one nuclear reactor in France, and I suppose it's the same in other countries, is close to 7,000 gigawatt hours. So in a certain way, it means that we need 3 nuclear reactors to provide the electricity required to deliver TVs in Europe. And if you look at the very right bar, you can see how that translates into carbon with about 5,000 kilotons of CO2 associated to the delivery of TV. This is scope 2. And you can see the same split between the 3 platforms. So very clearly, you can see that the delivery of TV in broadcast, and here it's only DTT, is much more efficient. And obviously, if suddenly DTT would be replaced by streaming, which is OTT, this would have consequences. So again, we start on the left side from 21,000 gigawatt hours. That is the current situation. If you turn off DTT, there will be a modest saving, 10%, of 2,000 gigawatt hours. But there will be a very important increment of about 12,000 incremental gigawatt hours needed to deliver in OTT the live traffic that has been shifted from DTT to OTT. So we would grow to close to 30,000 gigawatt hours, and that is a change of about 40%, and that is about another 1.5 nuclear reactor needed to power that transition. So maybe that transition as a starter is not an excellent idea. What can and doing this transition may also have a very significant cost. And the costs, we can estimate them based on a study published by ETNO in 2022. And this is a very, very interesting study. And in this study, the telecom operators made an estimation of how much OTT traffic was present on the European telecom network. Their calculation is 442 exabytes, and they estimate that this is costing 38 billion euros to them. From that, you can derive that according to the telcos, the delivery of 1 gigabyte of traffic on a fixed network is costing 2.2 euro cents per gigabyte. If now one would decide to shift the DTT traffic to OTT, it would mean shifting 336 exabytes of incremental OTT traffic. And per the metric or the price scale that the telcos are suggesting, this would mean 7.7 additional billion euro additional network fees. So that is a lot of money. So again, also from a cost point of view, shifting traffic away from DTT to OTT doesn't appear as a good idea. How can we mitigate that? And I think we can mitigate that with HbbTV. So as we heard it also from Meta, consumers are tempted to less classical TV experience. And you could summarize these less classical TV experiences as being VOD and application. And these VOD and application TV experiences, they are very much associated, one could say excessively associated, to streaming distribution model, even when it comes to linear. And we just saw that keeping the live TV watching on broadcast has some relevance from the point of view of energy, carbon, and cost. And HbbTV can help to do that. Number one, HbbTV enables the enrichment of the consumer experience with interactive services. And that is a good reason to mitigate the motivation or the appetite for consumer to move away from broadcast to streaming. If they find in broadcast the interactive services that they love in streaming, that is a good reason for them to stay in broadcast. Number two, if you look at it from a broadcaster point of view, one of the things that the broadcasters love about streaming are the easy addressable advertising opportunities which are created by streaming. Again, HbbTV can help that because in HbbTV, we have the HbbTV TA specification, which is enabling addressable advertising in broadcast linear TV. And that is also a reason or a help to remove one of the motivation of shifting from broadcast to streaming. And the third reason, which is probably excellently illustrated in the UK with Freely, is that with the HbbTV OPAP specification, you can create an app-minded experience for consumers, which in a certain way mimics or replicates a streaming consumer experience, but which still can leverage the efficiency of broadcast delivery for linear viewing. So these are three ways that HbbTV is helping greener TV watching. We have very close cousins in Geneva, which are the DVB specifications, and I can think of a few of them that also help in delivering or a greener delivery of TV. First one which comes to my mind is DVB-I. DVB-I, a little bit like the freely op-amp case, will enable the automatic selection of the lowest energy or low energy broadcast instance of a live program if it is available on a TV set. The second DVB child which comes into play is DVB-NIP. DVB-NIP will enable that the low energy broadcast delivery will be used to deliver the IP streams to non-broadcast devices, which are, for instance, tablets and PCs. And again, this will enable to use the low impact broadcast streams or bearer for IP style traffic. The third one is DVB-HB, which does the same, but without an IP transport stream. So in a certain way, you could say that DVB-HB is a little bit like an older version of DVB-NIP. Reality is not exactly that, but it aims at the same use case, with the caveat that with DVB-HB, you will need to locally decode the DVB transport stream and redistribute it as an IP transport or an IP feed to non-broadcast devices. And the fourth one is DVB-MABR, multicast adaptive bitrate, which is a great enabler for multicast delivery. And multicast delivery will save a lot of energy even where programs are delivered. There is another way that HbbTV and potentially also DVB can help to save energy in the delivery of content, and that is the famous push and cache approach. Very simple concept of push and cache is to differentiate in the VOD content, to look at the fat tail, which is about 50% of the usage, and to distribute that fat tail VOD content as a broadcast stream to homes of consumers. And you would store them into a local home cache unit. And you will bring that to the TV with a simple Wi-Fi connection. The long tail, which is the other 50% of VOD viewing, you will keep it on OTT delivery, and that will go by the normal path to the TV. If you do that, with an illustrative assumption that you can shift 30% of VOD viewing to the cache, you would remove about 34 billion hours into the 96 billion hours of VOD of Europe in 2020. You could remove about 11 gigawatt hours of electricity usage. This is about close to 2 nuclear reactors. No, sorry, you would save 3.8 gigawatt-hours out of the 11,000. So that is about half nuclear reactor, and you would save about 920 kilotons of CO2. That would be the potential benefits of the caching offload. So here will be my conclusions. TV delivery again has a non-significant energy and carbon impact. You can keep in your mind that close to 3 nuclear reactors in Europe are dedicated to provide the energy used by the delivery of TV. Broadcast delivery has a significantly lower energy and carbon impact. It's a 1 to 10 ratio, roughly speaking. So really the trend to all TV in streaming, which is highly appealing to end users, appealing to broadcasters, and very strongly encouraged by smart TV, is not a good trend from an energy and environment point of view. And this can be mitigated by HbbTV, which can help to mitigate the need or the desire to shift viewing from broadcast to streaming. And that can help the mitigation of the growth in the energy and carbon impacts of TV delivery. This is done by the HbbTV core spec, by the HbbTV TA spec, by the OPAP spec, and by the push VOD function of HbbTV. Other open specification which power the push and cache approach can also help to mitigate these impacts. And also other open adjacent standards can play a significant role. This is true for DVB-I, DVB-NIP, DVB-HB, and the DVB-NABL standard. So altogether, the open European standards can help to make the delivery of TV more sustainable. Thank you very much.
Thank you, Vincent, for these interesting insights and how standards and specifications can help improving the energy efficiency. Let's move on now to a few more technical details, and happy to welcome Robert from Fraunhofer Focus in Berlin to the virtual stage, who's going to discuss their side of things, green streaming, the role of consumers and devices. Welcome, Robert.
Yeah, hi everyone, and also thanks, Jörn, for the invitation. As you might know, we have been working on sustainability in media and streaming for the remaining or the last 3 to 4 years, really focusing on end-to-end supply chain and trying to measure and understand the energy consumption of the different components involved in the media supply chain for streaming. And therefore, we initiated the Green Streaming project, which is led by Fraunhofer Focus. And today I will try to focus a bit more on the end devices and the role that they play, and how we can find ways to improve energy efficiency when we use them for streaming. Yeah. This is the picture that we started with. I don't want to go through it, just to show you there are a lot of different variants and metadata and parameters that may influence the energy consumption of streaming along the chain, and especially on the end devices. We were very interested in understand, okay, what are the main contributors to the overall energy consumption. And therefore, we created a end device measurement framework that we're currently also extending for CDN and encoding. And our very goal was, of course, to have something that is reliable and that especially helps us to understand all the dependencies of energy consumption in terms of content attributes like complexity, the brightness, luma, color histograms, of course, codecs, frame rates, and all the technical parameters of the stream itself. Then we need to understand device attributes like display technologies, brightness levels, display modes, screen size, all those stuff, as well as network attributes like the connectivity type, bandwidth, jitter, and other technical stuff. This is where we started. We created a automated measurement framework that today helps us to measure in homes, in the lab, and also remote via cloud in real time, and especially provides all the metadata that is required to really understand the measured data and start to make some use of it and to derive insights that then help us to build solutions to reduce the energy. In this way, we compared at the beginning also different stream settings on specific TVs, and we measured them. What you see here is just one example of a TV. In this case, it's an OLED TV, and we just run the same content encoded in different ways with different bandwidth, different resolutions, codecs. And what you see is basically two groups of energy signatures: the blue, red curves on top, and then the green, orange curves that require less energy. And the basic difference here is not the codec, it's not the bitrate, it's simply the energy mode that we turned on a smart TV. So this is already one result. Energy modes do really help to save energy. And the other result here or finding is, of course, that there's not that much that we can gain in terms of energy efficiency from reducing the bandwidth or reducing the resolution, because, and this is a very easy explanation, typically, especially on smart TVs, also smartphones and tablets, all the decoding takes place on a chip. So it's very, very efficiently baked into a piece of silicon, which helps to run the decode with just 1 or 2 watts. And compare this to the screen size or the display that needs to be illuminated. This is why there's not that much gain, and it's more the luminance, the overall luminance of the actual display or the resulting image, so to say, that mainly influences the energy consumption. Of course, there's a difference between smart TVs and smartphones just because of the screen size, but at the end, this is one of the key findings that should be taken into consideration, and we try to find ways to use this information to really improve energy efficiency on devices, and therefore we did some more analysis, especially on the luminance. We started with some lab trials where we compared different brightness levels of contents on TVs and tried to measure it and evaluated also the effects out of that. We did this by using the mean opinion score as a very early and easy solution to just rate the overall quality of experience of the resulting content that has been watched in front of different TVs with different content types. And basically, and this is the main result here, is that video brightness, of course, can affect the energy consumption of consumer devices, and there is a certain way, a certain threshold, a certain range that we can benefit from by easily, let's say, kind of darken the resulting image in a range that the human eye is not able to recognize it, and this saves energy on the devices much more efficiently than reducing the bandwidth or the bitrate of a video stream. And yeah, we did a prototype implementation that we have been working on. This we call Famium Greenview. The solution is a kind of a mixture of a client library, so it could be added to any existing workflow that is out there without the need to manipulate the content itself. And the library sits on the client. It talks to a kind of a backend service where we used all the data that we created out of the project so far to provide the optimal settings for a dynamic overlay that we put on top of the video player that helps to reduce the energy consumption in a way that, as I said, the quality of experience is still guaranteed on the device. And don't want to go too much into detail of that. We have been also published a white paper within Greening of Streaming by end of last year, which covers all the major effects that influence those stuff here. But the main the main result is that we have been able to save up to 15 to 20% of energy compared to non-optimized streams without compromising quality of experience by using such very easy application on top of the players. And this is basically the thing. So we need to really focus on the issues that really influence energy consumption. And this is why I also put here, understand the problem. So end-to-end streaming is complex, as we also heard from the previous speakers. There are different aspects that need to be considered for all the different parts, for the contribution part, especially also for live streaming and all the peak management, for encoding, for CDN and distribution. Peter will also add on this in the next talk here. And of course, then we have end devices. And as we know, end devices are responsible for more than 80% of the overall energy consumption along the chain, if we include them. And talking about 80%, we need to focus on this, and we need to find ways to reduce energy there. And to do so, there are two things are key. One is to understand the end device and be able to provide recommendations for the viewers. And the other one is also to educate and engage the viewer to help them understand what they can do by it, for instance, use a different device in a different situation, or just understand how devices behave. And the easiest way, again, is enabling the energy mode that the TV is already bringing. There's another one. I just put it here as energy APIs are missing. So what we found is that if we want to try from an application perspective or service provider or broadcaster's perspective to reduce efficiently energy consumption on devices from viewers, it would be very, very beneficial to get some kind of metadata or at least device settings that tell the application which brightness is currently used, if the energy mode is already enabled, if a certain display is in use, or even a certain display mode like cinema, sports, whatever. You all know those various settings that you can apply on your TV. Because without of all those information, it's kind of a hard game to try to optimize the black box where you can't measure the output and you don't have the information about how the black box works. And if we could work together in the industry, and I guess HbbTV is the perfect place to do so, on establishing and defining APIs, energy related APIs for devices, we can then, of course, implement much more efficient ways of energy reduction and also tell the viewer what the devices currently are actually using, stuff like this. So this is an open call for all the involved parties here to work on those issues within the upcoming months and years. And we have been started with those initiatives already in Green Streaming Project at Fraunhofer Focus, and we are working on green digital twins that help us to estimate energy consumption, with the overall idea to be able to provide in somehow real time an estimate to the viewer for this certain setting for a specific type of content he's currently watching. And if we can improve this, I guess we have a very powerful tool to efficiently reduce those 80% of overall consumption in the media supply chain. And having said this, I would like to already close the session here. Thanks for your attention, and would just hint you to two websites. One is Green Streaming, where all the information, especially from the white paper that we created, is available to the public. And then there is, for all interested people out there, a sustainable media workshop as part of the Media Web Symposium, which we will hold in June this year at Fraunhofer in Berlin. Thanks a lot.
Thank you very much. And yes, I'll be there in Berlin, and big invitation to everybody who would like to discuss these and different issues in the value chain to join Focus Fraunhofer Mobile Media Web Symposium. Okay, let's move on to Peter for a few more technical details, especially regarding the streaming part of the chain and some interesting results that he would like to share with you. Thank you, Peter.
Yeah, welcome to the last presentation in this session. That's about distribution. I come back to that what was in the presentation from Vincent to say our view from of the Green Streaming project to the distribution part. There are a lot of different models to compare the different distribution technologies. And the basic models we are looking at, we looked at in the project are the energy intensity model and the generic power model. The left one, the energy intensity model, is data-based. That means that you calculate the energy consumption per data rate. That means for a stream, for a TV stream, you can really say how much energy will be used for 1 hour HD streaming, for example. But this model is not the right one from our point of view due to the fact that it leads to the assumption that more data generates or create more energy consumption, which is not the case. The model will be used mainly for reporting of telcos and so on. You can see it here, for example, for the different networks. These are figures which we found out from different studies. That is the main purpose of that model. A more concrete and better model is the generic power model, which is time-bit, which is saying that the energy is a function of power over time. And as you know, all the networks we are up and running have a lot of idle time, and the high energy consumption, or the biggest part of the energy consumption is at no load. That's really the case. During the night, you have only 10 to 5% of the data rate, which below the peak data rate, and the network is always using around 80% of the energy. That's what this graphic is saying, that from the conclusion of that is the current models give a common understanding of the current energy consumption, but for energy management and energy forecasting, we have a need for more predictive models, digital twins and so on, and to taking into account the very complex parameter sets we have. Let's have a look on the mobile and the fixed network of a telco operator with some figures. For the fixed network, the energy consumption has remained stable over the last years. That's why we also having in the reports, for example, of Deutsche Telekom every year, that for the fixed network, we have no increase in energy consumption. Of course, for the comparison I will show in the last slide, fiber is really the greenest access technology from the distribution point of view, not from the installation point of view. You need a lot of energy and CO2 to put the fiber into the earth. That's really the case. But from the distribution point of view, that's the greenest access technology after our analysis. And always, as in the whole chain, the CPE, that means the device you need to receive the signals, has the biggest part of the energy consumption, around 50 to 70%. Especially for the mobile network, is the radio access network part responsible for around 75% of the whole energy consumption. And another fact is that 5G is, from the energy efficient point of view, more energy efficient than 4G, but the absolute power consumption per cell is higher due to the higher antenna numbers and so on. That's really the case. We are analyzing that currently, but that is what we have measured really the case. We have both on different cells up and running, 5G and 4G, and if the capacity of 5G is going up, then the energy consumption is going up. And always for this network is the same, around 70% of the total electricity consumption is at no load. This is what we found out in our project for the comparison of the different distribution technologies. We want to make this very simple and transparent, compare the different technologies, and but is always what you can find out in the literature based on the models I presented. And the assumption is very simple, that we have an HD stream per 1 hour, and we calculate the energy consumption per line, not per customer, per line to a household. We use the generic power model. The DVB-T values or figures here are only valid for Germany. If we have a line model, that means we are calculating the line per household per customer. In Germany, we don't have only 2.3 million customers, so that's explains the higher value here for DVB-T than for UK or France. And for cable, satellite, and DVB-T, we are just looking at broadcast, not at streaming. So you can see here that fiber is really the best technology for distribution for a telco operator. And for the broadcasting is satellite the most effective technology to distribute TV signals. What you can also see here is that the CPE is the biggest part in this comparison, and for the access technologies, you don't see so big difference between all these technologies if you are looking at the power consumption per line. Let me give a short summary of my presentation. Is that the energy consumption in a network is not driven by the data demand, that is mainly driven by the time when the network will be used by the customer. And we have really a high energy consumption for all technologies at no load. Fiber is for the telco, the greenest, for streaming, the greenest access technology, and for broadcasting is satellite. And the most effective measure, that's also for us as telco, the outcome of a study over the last, of the experience over the last 3-4 years is the hibernation or the shutdown of components. That's the most effective part. For example, if you are looking at the usage curve of TV over the day, that means that the most of the TV users you have in the evening, then you can shut down some of your components during the day or during the night. That's one of the effective measures you can do. That's the end of my presentation, and thank you for your attention.
Thank you, Peter, for rounding up this webinar with these interesting insights. And of course, capacities not being used are really, to put it into frank words, a waste of energy. And I think that is an interesting learning from your presentation. So let's welcome everybody back to the virtual stage for this just very brief, because we're running out of time, Q&A. All of the questions, funnily enough, are for Vincent. So his presentation seems to have had the most impact and most reflections. But of course, if anybody else would like to comment on these things, I was happy to do so. First question was for the Vincent is not there yet. Vincent, please log on and
yes,
look at
I'm
your
here.
questions.
I'm here.
There you are. Okay.
I'm here.
It's that two different logins again. So Vincent, first question, do the energy calculations for push and catching include the energy cost of building, distributing, operating the hard disks? There is, of course, always an important factor. Does the hardware factor, what role does the hardware factor play here? Also with DTT, I mean, you have to operate DTT, transmitters, transmission towers, and all of these things. So what's your response to that question?
Very direct response. In the numbers which I showed today, these caching costs are not included, but I have other results which I have not shared today where these costs are included, and the short answer is that they eat less than 10% of the savings. So I presented the gross saving, and the net savings will be about 90% of the gross savings.
Okay, thank you. Next question is also for you, Vincent. With the telco cost calculation, would this be different if MABR is used?
Well, I'm not sure that MABR could be used if it's not live traffic. So if it's VOD, of course, if it's live traffic and you use MABR, yes, the cost would be different. And by the way, in the initial model, IPTV, on the IPTV, which was the purple part, multicasting was factored into the telco cost.
Sorry, next question also for Vincent. Very interesting. Speed your results and suggested solutions are valid for Europe. Are they also applicable for other regions like North America or the Asia Pacific region, or do they face similar issues?
Well, I'm not too sure because I've not been so much in contact with this region on this topic, but my intuitive answer is that issues and results are going to be roughly the same. Incidentally, in the satellite complement of LOCAT, which is now being produced, North America and Latin America will be factored in. So that's going to be an easy way to check if things look the same in these regions.
And this already leads to the next question for you, because this viewer mentioned that some of the comparisons and assumptions in your study are outdated, perhaps, or not up to date. So will there be an update of the LOCAT study coming up?
It's not exactly an update. It's going to be a complement with satellite, but it's not exactly an update. So I absolutely acknowledge that it would be very much worse to update the numbers, which now are 5 years old.
Okay, so there's new facts and figures coming up from LOCAT to be looking forward to. A question for Peter. Peter, can you please clarify, as your slide said, DVB-TEC is valid only for Germany, whereas the slide shows T2. Is one of those incorrect, and is it only for Germany as it's based on the number of viewers in Germany?
Yeah, that's really so based on the numbers only for Germany. It means if you have bigger numbers of customers, then the line consumption per 1 hour each the streaming will be lower, definitely. That's just a linear correlation between the power and the number of customers.
Okay, so I think Ben wants to comment, and then Vincent.
Yeah, I just wanted to comment on Vincent's first question and answer, is that one concept that didn't come out much here is the importance of the energy mix in a market. We did a study with Orange about 2.5 years ago. So an operator like Deutsche Telekom or Orange saying, should I replace my CPE? Say this new CPE is 40% more efficient than the old CPE. Well, in France, if you were to do that, if Orange was to say, I'm going to replace this device because it's 40% more efficient, I'd have to run it for 23 years before I'd get the money back, because the difference between embedded carbon and energy will vary wildly. Whereas if you're doing it in Poland, the same question for the operator in Poland, it only needs to run the device for 3.5 years for it to be good for the planet, the new device that's more efficient. So Vincent's question and answer about hard disks is totally different. So just to give you some high level figures, seen from planet Mars, everything that humans produce is about 50-50 between the embedded carbon and the energy. I'm talking about devices that run on energy. And in our area of streaming, we've studied lots and lots of devices, and it's funny how it's typically, it goes from 80-20 to 20-80. Typically an iPhone will be closer to 20% of its carbon. Actually, it's more like 15 is due to its energy, and 85 to 80% is due to its embedded carbon. And at the other extreme, devices run by Deutsche Telekom in their network, they're very, very efficiently run. So it's more like 20-80. So typically a network router, its embedded carbon would only be 20% versus 80% for the energy it uses.
Thank you. I think that's interesting, these local factors to be looked at. Ben, there is a question directly for you. Is the Greening of Stream initiative also investigating the value chain of the content, meaning looking at the producers, broadcasters, cable, telco, and OTT providers for transcoding and encoding multiple times by the different stakeholders?
So when you say production, we're not involved in the production as in creation of content. There's a lot of work that's been done on that in multiple countries, and how you produce content, sending streams out. So we're not involved in that. That's out of our scope. Obviously, we take the content once it's been made by the filmmakers or the sports producers or whatever, and then all the different kinds of encoding, transcoding, we're working on all of that. Once the content's been made, it comes into our domain, and we're looking at how do we distribute that through streaming.
I think that's one for Peter. Why is the CPE for cable customers almost double than that for other access networks?
Yeah, that's an interesting question, but it depends on the amplifiers you have in the boxes, I think. But these values are really taken from an official table from the European Commission, which will be published every year. That is just that is a table where the telco manufacturers for telco equipment giving their current figures for their devices and an outlook for the next 5 years. This is really taken from that. So I don't have a cable box, but I think that seems to me that has to do some the line and the cable box. with the amplifier.
Okay, thank you. Vincent, and then I think we are running out of time, just quickly.
Yeah, I just wanted to make a brief observation to Robert and Ben, who seem to work hand in hand in green streaming. And it would appear that your work is really focusing on the TV set. I was curious if there is any findings, any thinking of greening and streaming on the delivery part of streaming, the network part, not only the viewing part.
So
Robert?
the reason. Okay, go ahead, Robert.
Ben?
Okay, so maybe I can answer also for greening of streaming. It's a bit
Okay.
okay. So
You
we are
remember,
doing
so
green.
you're
There's a difference between the green streaming activities that we do at Focus, and there's greening of streaming where we have been also publishing and helping to support, which is what Ben is chairing. So of course we are also doing end-to-end observation. I was asked here in this round to provide some insights from the end devices perspective. I still think it's very valuable because it's the major part if we look at energy consumption along the chain. But we're also working on distribution, encoding part of things, and we do also have a partner with Logic Media Solutions from Germany. They are very active in the live production, which is also one question here. What I just wrote, that also live production and the impact of live sports events is very important. We're also looking into this and trying to compare modern IP-based contribution signals versus traditional SNGs and stuff like this. So to have a short answer, yes, the scope is much wider. For today, I was just presenting the consumers and devices point of view.
It's a complex issue, and we could probably add another hour to this webinar, but we've already run out of time. So sorry for that, but I'm sure we'll pick up this topic again in one of the future sessions of the HbbTV webinar series. I think the conclusion is that a lot of collaboration is required. Also, education is important. So it's great that initiatives and companies, organizations like you represent, are dealing with this important topic, because there's so many different aspects in this value chain involved that can make a difference. So thank you very much for taking the time, to the speakers and to the audience for watching this. Very final last word from my side here, of course, looking at the HbbTV Symposium coming up on the 12th and 13th of November in Istanbul, where these environmental issues are certainly going to be part of the sessions. And then, as usual, if you have any ideas for further topics for the HbbTV webinar series, please send them by email to webinar@hbbtv.org. And for further updates on HbbTV, on the webinar series and related issues, everything's got something to do with HbbTV, please check out the LinkedIn page of the HbbTV Association. Thank you very much for this time. See you next time and take care. Goodbye for now.
Thanks.
Bye-bye.
Bye-bye.
Bye.
Bye-bye.